Okay, in this video, we're going to try adding and subtracting rational expressions. You're going to need to be able to do this with like and unlike denominators, both. So in order to understand how this works with algebraic expressions, let's just remind ourselves really quickly how it works with normal fractions. So 1 over 8 plus 3 over 8. We know we can add these together because we have like denominators. That means the 8s are the same. So the 8 just gets brought along and he gets written into our final answer. But on top, that is where we actually add. And so for that, we get 4. If you ever end up with a fraction, you do want to reduce it. And so that means this reduces down to 1/2. We're going to be doing this in terms of factoring and reducing and things like that. Looking for GCFs, just like we did with multiply and divide. Unlike denominators, now I see that I want to subtract these two fractions and there's a 3 and a 2. Can't subtract them because the denominators aren't the same. So we are going to actually try to create new denominators. I'm going to do that by turning them into the same number. I don't want to turn them into some huge number, so let's turn them into the smallest number we can. So here we're going to turn this into 6 by multiplying by 2's, and over on the other side into a 6 by multiplying by 3's. We end up with two new fractions, 4 over 6 minus 3 over 6, and our final answer is 1 over 6. Again, you want to keep that denominator. You do not want to subtract it. But on the top, we do want to subtract the 4 and the 3. Okay, now let's start trying this with algebra. So I look first, are the denominators the same? They are, x plus 1, x plus 1. So we can go ahead and keep that denominator all the way into our answer. So let's write that first. And now we're going to want to subtract the top. So 2x minus x. 2x minus x. What is 2x minus x? Well, that would just be a x over an x plus 1. Remember, you do not want to cross off those two x's because on the bottom that x is attached to the 1. Whatever happens to him happens to the 1. And if there's not a plus 1 on top, then nothing can happen to him. So it's actually as small as it can get. Before we move on into uncommon denominators, unlike denominators, it's important to see if we can find what's called the least common multiple. Meaning, what is, if we multiply things together, what's the least thing that they both could turn into? Well, in the first one, we have xy and 2y. So they both have a y, but one has an x and one has a 2. So the smallest multiple would be a 2, an x, and a y. For 5x and x to the third power, well, one has a 5, one doesn't, so they definitely need a 5. And they both have x's, so the least one, so that they have the same thing, is x to the third power. So now it includes everything from both, without going bigger than what I had to begin with. Here I see that I have 3x plus 5, 3x plus 5x plus 2, and 3x minus 5, and 5x plus 2. They both have 5x plus 2, so that's definitely going to be in my multiple. Now one has a 3x plus 5 and the other one has a 3x minus 5. Those things are different, so we do need both of them for our multiple. This is the least common multiple. Now I'm looking here. I see that one has a 2x and one has a 5x. They both have x plus 3, but one has a square, one doesn't. So if for a multiple, I have a 2 and I have a 5. I can't turn a 2 into a 5 or a 5 into a 2. So the least common multiple of those two things would be to multiply them together, and that's 10. They both have x's, so that's as small as I need. They both have x plus 3. And to make sure I include both, one has only 1 and one has 2. So the least that includes both would be 2. The last one looks a little different, a little funky. This is a little more like what you're going to be expected to do. I could just say that the least common multiple is those two things multiplied together. Or I could try to do a little bit of factoring. So let's try to do a little bit of factoring. GCF the first one. GCF the second one. And maybe hidden inside that trinomial is an x plus 5. It's going to be x minus 5 and x plus 2. So now I see between all those pieces is that one has an x plus 5, one has an x minus 5. So it wasn't in there. So really, our GCF in this one, after seeing what factoring gives us, is all of that together. It is 3 times 6, and that's 18. The x plus 5, the x minus 5, and the x plus 2. This is the least common multiple of those two things. So let's go ahead and start this problem out by factoring the bottom to see how could I get the denominators the same. So I end up with, I can pull a 3 out, and I can pull an x squared out. And I'm left with a 2 and an x plus a 1. So this is what I got. That's, let me move this over to make a little bit of room. So what do they both have? They both have a 3. Check. Don't need to add, don't need to give anything more that way. I also both have x's. Good. One has an x to the power 3 and one just has an x to the power 2. So on this side, I do need to give this an x. So that means that I'm also multiplying the top by an x. Now on the left, I don't have the 2x plus 1. So I'm going to multiply this side also by my 2x plus 1. And what should we do to the bottom? We also do to the top. After I do this, the denominators will actually be the same. So I do have a little bit of distribution I got to do here on the top. 2x times 4 will give me 8x times 1 is 4. On the bottom, I now have my new denominator. X times x is x squared. And I now have my new denominator also here. I'm getting x cubed because x times x squared gives me x to the power of 3. Now that the denominators are the same, I can go ahead and add the top and keep the bottom. So what I end up with is our 3x cubed times 2x plus 1. On the top, there's no common terms at all, so I'm just going to keep that exactly as it is. I'm going to put it in standard form, so put the x squared first, then put the 8x, and plus the 4. Now, do you think there's going to be a way to factor that x squared plus 8x plus 4? I don't think so. So we're going to leave that as it is, multiply the bottom, and write our final answer. And so this is our final answer, with no really extra reducing that we need to do. Okay, let's take a look at this problem. Look, see if there's any factoring. I do notice that both my denominators have a GCF of 3. So let's go ahead and factor that out. And over here on the other side, pull out the 3, x squared plus x minus 2. Now I'm looking at these trinomials, and maybe there is a way to factor these more. I think there is. So I'm going to go ahead and try to factor them a little more before trying to subtract. So this is going to be x minus 2 and x minus 1. And on the other side, no GCF on the top, so leave it as it is. And I know that this is going to be x plus 2 and x minus 1. I'm looking at the two denominators. They both have a 3, so I don't need to give anything there. They both have x minus 1. The only difference is one has an x minus 2 and one has an x plus 2. So that's what I need to give to each side. To the left side, it needs the x plus 2. And to the right one, it needs the x minus 2. Now, there's a little mistake that sometimes gets made. When they write down this, they think sometimes, oh, I'm only going to distribute the 1 to the x and the negative 2. Do make sure that that is being multiplied to everything on the top. So you are going to want to maybe add in your parentheses from time to time. Okay, I got some multiplying to do, some new denominators to write. So let's get to that. So x times x is x squared. X times 2 is 2x. On the bottom, let's leave things all factored out first, just in case. You know, you never know if there'll be something you could reduce. So I have my 3, my plus 2, my minus 2, my minus 1. And here, I end up with 2x squared minus 3x minus 2. And my plus 2, my minus 2, and my minus 1. Okay, so, maybe after the subtraction I can factor, but right now it's time to subtract. My denominators are the same, so I'm going to keep the denominator, but on the top I am going to subtract. Now you do need to make sure that when you're subtracting everything. So I kind of want you to remember that this is subtracting to each of these things. So there's some sign changes that happens. So on top I have x squared plus 2x. Now it's a minus 2x squared. Now it's a plus 3x. And now it's a plus 2. And on the bottom I still have my denominator. Let's combine our like terms. So I have x squared minus 2x squared is negative x squared. 2x, 3x makes 5x. And then I have my plus 2. And this will be all over. Now I'm looking at this, and I don't think I'm going to factor this at all. You know, my negative x squared plus 5x plus 2. And I don't think there's going to be a way to factor that. So I'm going to go ahead and start to multiply all of this out. And when you multiply it all out, you start getting 3. Let's multiply the first 2. So that's x squared minus 4. Let's multiply those 2. You get x cubed minus x squared minus 4x and plus 4. And the very last thing you need to do is to go ahead and do that GCF. I'm sorry, to distribute the 3 back in, which was the GCF in the beginning. And this would be our final answer. So there's a lot that we have to do. Break things apart, put them together, put them back together again. You know, it's kind of like, some engineering. You got to like break it apart, look at the pieces, and then figure out how it works to put it back together. Okay, in this last one, I wanted to show this one to you because this one seems kind of tricky. At first glance, maybe you think that the denominators are the same. One has an x and an x, the other has 4 and a 4, so they must be the same. But do know, remember, x minus 4 is not the same as 4 minus x. Just like, 5 minus 2 is not the same as 2 minus 5. So let's turn this one around first and see what it is. So we get a negative x plus a 4. And let's rewrite the first one. Now I see that they are not the same denominator. One has a negative x, the other has a positive x, one has a positive 4 and a negative 4. So how can I get these the same? Well, I can multiply, to make a negative x into an x, I can multiply by negative 1. To make the 4 into negative 4, I can multiply by negative 1. So maybe that's actually what I want to do here. Let's times this by negative 1s. What you do to the bottom, you do to the top. So now I have a negative x minus a 2 on top. And now negative x times negative 1 is x. And 4 times negative 1 is 4. So now my denominators are the same by multiplying by that negative 1. So now it's time to, again, keep the bottom. And since it's add, we're going to add the top. So 5x plus a negative x is 4x. 6 plus a negative 2 is 4. Do I have a GCF here? I do. So let's try to pull out the GCF, and we'll see what we end up with. X plus 1, x minus 4. X plus 1 on top, x minus 4 on bottom, those are not the same thing. So actually, it didn't help us to try to do that. So this is our final answer. Okay, so that's adding and subtracting with like and unlike denominators. I know sometimes it can be a lot of work, but if you stick with it, you will get it. If you have questions, leave a comment or email me, and I'll see you back in class.